So before we get started, I thought I would take the time to bring out one of the current modules and show you what's going on. We like the proportions. It's 4 foot long by 2 foot deep by 4 inches high. We like the track plan, which is basically flat for this particular module. This one is pretty common. We like the fact that it is a solid piece, although this is made out of pine, and the only mechanical fasteners that you see are a couple of screws. It looks to have had 2 ribs that were added later. It has a front fascia, which actually houses a piece of plexiglass, and over that there's some Velcro here for some skirting. Now there's some things that we don't like. First of all, it's very heavy, and that's possibly due to the fact that this is solid wood and it is pine. It's very loose. I can lift up one end of the module and the other end stays put, which means all of these connections are very loose. And if you take a look even on this side, you can actually see that this particular piece is actually split and it's broken. I've turned the module onto its side so that you can see what's going on underneath. The wiring is actually done very well here and it's very organized. However, the rest of the module has a little bit of an issue. Let's take a look at a few of those. First of all, it's made completely out of pine, so I know that the module is actually shrinking. These 2 cross members were actually added later and they're not even connected to the top. The side is put together with a straight butt joint, which means that the screws are actually drilled into the side, and that tends to have a problem. And this side has the wood is even split. It's actually not even connected at the bottom. I don't even know how it's being set up. You see some discoloration because of water and colors like that, as well as this particular cross member is actually warped even after it's been applied. It is painted, but it is not painted on the bottom. Therefore, as moisture expands and contracts with humidity, this module tends to move quite a bit. So let's put it back on its front. The biggest issue with wood projects, as in any project, is wood movement, and that has to do with moisture in the air. Temperature and humidity expand and contract wood. And modules are no different. However, we tend to think of modules more like a utility table rather than a piece of furniture. That's a mindset we need to get out of. We need to start treating these like they're a piece of furniture. After all, these are models in and of themselves. So it's best to start building them just like they were actually a piece of furniture and use the appropriate techniques where warranted when it comes to building modules. I've set the module on its side so I can give you a closer view of what's going on here. The whole module has been made out of a frame style construction. 2 rails, 2 cross members, and then a piece of 1/2 inch plywood applied to the top. That actually held the whole thing square for some time. But take a look at this. This is actually a butt joint where the rail is actually driven into the cross rail at the front. This joint gets a lot of stress. It gets stressed by being pulled. It gets stressed by being the weight. It gets stressed by the length and the weight of the cross rail, as well as being stressed by being pulled in both 2 directions, as well as temperature and humidity. So this joint will actually at some point start pulling inward and come out of square. There's a better way to do these joints, and we'll take a look at some of those. And if you look at this even a little bit closer, you can see that this cross member is actually split, which means that there was so much stress on it at one point that it actually split on its own. This, coupled with the material, coupled with the poor design, actually caused this issue. You can even see down here that a piece of the wood has come apart. We need to fix that. So let's talk about span strength for just a minute. The longer the span, the stronger the material that is going to have to be in order to stay straight through the entire span. Most everybody's seen this before. If you have a shelf in your house that spans a certain length, you can actually see even in the center that you have a slight dip. That usually means that it's the weight in the center is not as strong as it would be in the ends. We don't have any support in the center, even for modules, so we have to understand that. Anytime you get past 3 feet, the span becomes a problem. So we need to address that. when we look at span, we also look at a couple of other options. The type of material that is used with spans also determines its strength. If we use a piece of solid wood over time, you can see, if you look at the piece of wood, all of the fibers of the wood are actually going this way, which means that even by itself over the course of time, that piece of wood will actually tend to sag on its own. So we need to address that as well. So the design will have to take that into consideration. Now, the taller the piece of wood, the more span strength that you have. In our case, the piece of pine that was used was about 3.5 inches thick. Therefore, in the center, this does have a little bit of a dip, which causes a lot of stress on the outside joints, both on the left and right side when you're looking at it. So we both need to fix this joint as well as deal with the span. Cross members will help, but it doesn't fix the problem with weight, because what happens is the cross members are actually only connected to two separate sides. As that weight in the center tends to come down, these will actually angle, causing more of a problem. So our design will have to take that into consideration. Let's talk design. Now, typically everybody who designs a module actually designs basically the track plan. Well, that's not what we're designing here. We're actually designing the module in and of itself, the infrastructure in order for your track plan to work. Now, there's a couple things we can do with design. Now, with that being said, this one is a very basic design. It's a box, and on the box is a tabletop. Very basic design, and we're actually going to build one of those and show you some techniques for it. However, we want to improve on a few things. We want to make sure that the joints along the corners and the cross rails are actually more stable, as well as they stay accurate. We can make a better way to align each side. There's a couple of possibilities for that. We want to make sure that we can have accessibility to put a back panel on here or a back drop. Have the ability with the appropriate cross members to start making risers. That's something that is really not done in modular railroading, but we want to start looking at that. That way we can have different heights and in some cases multiple levels. We want to make it lighter, and we want to make it easier so that we can transport it. Perhaps we could put in some handholds and handrails. Well, we got a lot of ideas. We'll go back to the drawing board and show you what we've come up with, starting with the basics. So before we actually build any modules, we need to figure out what we're going to use for material. When you go to the local home center, you're actually going to see a lot of this, or this. This is what in the builder's trades called as SPF, spruce pine fir, and it's designed for the building trades so that they can build walls or trim work or something very quickly. 90% of the time when you go to the home center, this stuff is still wet. And even if you take it out when it's somewhat dry, the likelihood is that it's going to be still wet for quite a while. This is why it has a tendency to warp and cup, and as well as disfigure in any way. A couple other things I wanted to show you here. If you take a look at this knot, on the left-hand side of the knot, you actually have this nice sweeping pattern. That's actually not a good thing. You look on the right side, the pattern is very tight. That tells me that the grain is going up and down, and really that's what we want to deal with our spans. But this is really not a good wood to use. It's a soft wood, it's cheap, it shrinks, it moves, it cups and curls, and if you don't protect it, it's going to get worse. The second choice when you go to the home centers is this stuff. This is called knotty pine or #1 pine. It's used for trim. You probably have it in your house somewhere. There's a lot of little bitty knot holes in here, and that also affects the wood. You can see that also in the center of this piece is where you get the pith or the center of the tree, and on the outside is actually where all the strength is at. If I were to put this on a 4-foot span, my guess is it not only will cup, but it will also curl as well as start sagging in and on its own weight. So these aren't really too good to use for modules. If you're going to use this wood, make sure that it's extremely dry by getting it with a moisture meter. Other than that, leave it in your garage for a year before you actually do anything with it. However, once it's in place and you protect it, it's really not that bad. If you're looking for other types of wood at the home center, you might consider one of these. I've actually found these in my local home center. This is soft maple. There's a lot of poplar. There's oak. And then in this case, this is walnut. I actually found this in one of my home centers. I don't know if it was a fluke or not. Soft maple is the soft version of the hard maple that you see in hardwood suppliers. It's a good wood. It actually spans pretty well, but it does have a tendency to cup and curl. And that's because it is rift sawn, which means it goes along the pith. So you'll see a lot of the center of the tree. It's still pretty strong, but I don't know if I'd use it as a primary wood for my rails or cross members. Take a look at poplar. Poplar is a good secondary wood. A lot of times you'll have to deal with these knot holes, but sometimes that's okay. The wood itself is pretty strong. It's relatively inexpensive, and the grain pattern is pretty straight, even towards the center of the tree. It's a pretty good secondary wood. The next type is in this case, is an oak. I'm not sure if this is a red oak or white oak. My guess would be a white oak. But the grain pattern is very straight. It's very strong. You're going to pay a premium for this, but it is a pretty good alternative than trying to dealing with some of the softer woods that are available. So your module will actually stay straighter for a lot longer period. However, can be tough on the blades. It can also be tough. Make sure that if you use this, that you pre-drill every hole. The final thing is what we call a premium hardwood. If I want an absolute gorgeous finish on my module, I might go with something like this. This is a walnut. Walnut is just as hard as oak, and in some cases even more harder. It spans pretty well. The grain pattern is very straight. It's pretty good with the tools. It cuts very well. However, this has a tendency to have some discolorations in it. If you take a look, even on the outside, the sapwood tends to have a lighter color. So if you're going to use this and use it to stain, you might have to deal with some of those problems. However, any one of these woods will do for building your module. However, I'm going to look for an alternative, and that's where we get into what is known as the sheet goods. Now, there's a variety of sheet goods that are on the market. You have your plywoods, and even in your plywood you have several kinds and several dimensions, as well as you have several different flavors of MDF. Now, plywood is nothing more than a series of plies. It can be cut into any size. It's fantastic for putting up on the side because it has a lot of vertical and horizontal strength. And that's because the pattern of the fibers actually are crisscrossed inside of the wood fibers. You can have as few as 3 plies, or you can have as many as what you see here. Now there's 2 types of plywoods here. This is a 7-core ply, and this is a 15-core ply. Basically what that means is that there are 7 layers of material all cross-patched over each other with a veneer on both sides. This one happens to be maple. This is a Baltic birch ply. In some cases it might be called Russian plywood or whatever. It's made from anywhere between 7 to 11 layers. It has glue. There's no voids. It has a premium veneer on both sides. This one happens to be poplar, and every layer inside here actually is a hardwood versus the 7-layer, which every 3rd layer or every 2nd layer is hardwood. You can get it in a variety of sizes, but I'll caution you to the wind. Even though things are sold as 3/4 inch plywood, they're not exactly 3/4. And if I run my finger across this flat edge, you can actually see that they're actually different sizes of height. So you have to deal with that. And we do have a way to work with that. We'll show you that to you later. The final sheet good that's available here is actually an MDF, medium density fiberboard. It has a lot of vertical strength. It has a lot of horizontal strength, as well as the ability to be used as a tabletop. It is a little bit heavy. It doesn't hold screws very well because it's a fiberboard. It's basically sawdust that's been glued together. It cuts phenomenally, and I tend to use these more at the top. And in some cases, if you want to use it for your top of your modules, you can do that, but I don't think I would use 3/4. I might use maybe a 1/4 inch, 3/8, or 1/2 as a maximum. It does tend to get very heavy. So whatever material you're going to use, you're going to need to have a bunch of fasteners. We'll take a look at those next. The fasteners, there's really only a few that I really use. However, you need to use the right fastener for the right job. Here's a few of them that we actually have here. Now, everybody's seen these before. This is actually a drywall screw. You pick them up at your local home center. They come in a variety of sizes, starting from 3/4 inch all the way up to 2 or 3 inches. And they come in a variety of not only screw sizes, but also number of threads. If you're using your hardwoods like oak, maple, and so forth, you probably want to use the finer thread. If you're using the softer woods like pine or soft maple, you probably want to use the coarser thread. However, take a look inside. You might not be able to see this, but if you look at this, is a bugle head or a drywall top. So it actually has a curved top, which creates a little divot where it needs to go. A lot of times you'll have to pre-drill in order for that to sit nicely. This is an actual wood screw, and these are what I use when I can. It actually has a self-tapping screw. It has a number of medium teeth. It has a shank that once it goes in far enough, it'll stop actually cutting. And of course it has a beveled top, and even the top has the ability to drill out a little bit. It has a star drive, if you can see that, but that star drive allows a lot less ability for it to be threaded out with a screwdriver or a Phillips head driver. The next type of screw that I use a lot of are these. They're pocket screws. Has a self-tapping screw. You can get them both in fine and coarse threads. It has the shank, but it has a flat bottom. And when it goes into the pocket, it sucks the two pieces together. We'll be using a lot of these. They come in a variety of sizes, and everything from 1 inch to 1 1/4 all the way to 2 1/4. We'll only deal with probably 1 or 1 1/4 for our project. The next thing I'm going to use is what is called a domino. Now this is sort of an add-on component, and the reason I'm going to use it is in my corners, and I'll show you that when we get to that point. But this is actually like a loose tenon, so when a piece of wood actually feeds into the other, it actually creates an even tighter bond and making the joint even stronger. It does take a specialized tool in order to create one of these. There are even ways you can use a router to do it. But if you don't have the specialized to it, you can still create very strong joints using pocket screws and butt joints. And we'll see that as we move along. The final fastener is the one I use the most. Glue. If you don't have this, get it. Now, with glues, there's different types. There's original, there's ultimate. Basically, a standard yellow glue would apply here. However, if you want additional strength, make sure you get the waterproof glue. The likelihood is you're going to be putting scenery on your module to begin with, and it's going to have a lot of water. You don't want that seeping into that glue joint. So all of your fasteners that are listed here are easily available through the home center. Let's talk tools. Well, you don't need to have a big shop or a lot of fancy equipment in order to cut wood accurately. You really only need a few tools in order to create everything we need in order to build a module. You'll need something like this. Circular saw, 7 1/4 inch, and it has the ability to make sure that you have cross cuts. Make sure you have it's centered, it's squared, and that it does what it's supposed to do. But you might want to change the blade out. Sometimes the blades that come with it could be pretty aggressive with your material. They make a variety of blades, everything from fine tooth to coarse. So in our case, for cross cuts, we may want to go with a finer blade. So check that. Make sure that it's squared and actually accurate. The next thing is a tool like this. It's known as a jigsaw, and you have the teeth actually go up and down, and it's designed to actually make curves, and we'll be using a lot of this. However, I wouldn't make straight cuts with the jigsaw because the blade can actually go drift from one side to the other. In order to make accurate cuts, we need to have it at 90 degrees. Couple of drill drivers or impact drivers to actually drive screws and drill holes. You have a series of squares and make sure that your cuts are actually done. Here's actually small square. I even take this to the home center when I'm actually picking material. I want to make sure it's as square as possible. Here's a square, a framing square that we can use in order to make sure that our cross cuts are actually square. We put this on the side of the board, and actually we use this as a guide for our 7 1/4 inch circular saw. Finally, the thing that you're going to use as well is you might need one of these. So when you're pulling pieces together, you probably want to clamp it before you screw it. The reason being is because you want to make sure that it's in the right orientation and in the right setting before you actually screw the screw. Pocket screws, butt joint screws, all of them have a tendency to move even after you start screwing. So there's a variety. There's a bar clamp like this, or a different type of clamp, typically what we find in the home center. All of these will work. The final tool that you're going to need are a bunch of these. You're going to need to mark things accurately as well as with a tape measure. And then the last tool we're going to need is a lot of this, sandpaper. Make sure that you have sandpaper on hand just to make sure you can shave off any of those excess splinters that happen after you make the cut. Also, this helps make sure that the fibers are put correctly after the crosscut, especially on aggressive blades. So make sure you have some of that on hand. All in all, that's really the tools you need in order to build your project. However, with these larger tools that are out here, all that does is save time. Everything we can make, we're going to make with at least one of these. And we'll show that as we move across. So I thought I'd take the time to show you about proper technique in cutting a board with hand tools. But before we use any power tools, it's time to talk about shop safety. Be sure to read, understand, and follow all the safety rules that come with your power tools. Knowing how to use your power tools properly will greatly reduce the risk of personal injury. And remember this, there's no more important safety rule than to wear these safety glasses. So to get started, the first thing we need to do is to find out if the board is square. So in this case, if I take a look at this, the end is actually not square. So we're going to cut this end square first. Then we're going to measure the length of board that we need, and we'll use the triangle to help square things up. It's a little construction tip that we can use. So to get started, the first thing we need to do is to put the square on the end of the board. And we need to support the board. In this case, we're just going to use this table to support it. I bring the square all the way up to where I need to cut, and make sure I get enough meat on the end of the board so when I cut it doesn't fray. Hold it down, hold the square against the board, and just make the cut. And now we check it for square, and that's pretty good. So now we need to measure for distance. So I want to mark, let's call it 10 inches from this board. Mark 10 inches from the end, use your square, and strike a line. Now, this is the piece I need to keep. This is exactly 10 inches from this end to this end. This is considered what are called the offcut. So when I place my blade against the board, I want to make sure it's to the outside of this line. Lined up with the line, but make sure it's to the outside of the line. If I were doing it in reverse, I would make sure that the blade would be on the inside of the line if this was the offcut. So let's line everything up, we'll make another cut. Check it for square, and that's perfect. Also check it for distance, just to make sure that it's also not longer. Exactly 10 inches long. I think we did good. Now let's talk a little bit about joinery. What a butt joint is where a piece of wood is perpendicular to another piece of wood and it's screwed together. So I'm going to do this joint to show you the strength of this and how to do it properly. First and foremost, the pieces of wood need to be square, both on the ends and on the face. So what I did is I actually drilled a couple of holes inside the end of this and countersunk them. And then I drilled the corresponding holes inside of here as one piece. It's a little bit difficult to put together and hold it in alignment, which makes this a little bit difficult. So first one I'm going to use is I'm going to use a screw design, a drywall screw designed for soft woods. In this case, it is a coarse thread screw. We're just going to drill that right in. As you can see, it's very difficult to do. I'm going to take this out. The best approach is to actually sit the piece on its side instead of trying to do it on the top. So it's a little bit easier to maintain. It's just a matter of holding it in alignment. And sometimes you need to just come up to the end. Hold it in alignment and then screw it in place. Then what I'll do is I'll take a fine screw and do the same thing. Now, they both went in pretty much the same way, but this is what I wanted to show you as far as strength of the joint. While it is strong by itself, and when it sits inside a module is moving around. It's always moving around. It's moving around with changes in temperature and humidity. It's moving around during transport. It's even moving around when it's being set up and taken down. So the strength of this joint is actually paramount to the success and the stability of the module. So let's say the module was sitting this way. This would be the front edge or the facing edge, and this would be the side, or another module would connect it. So this joint would actually be going in and out pretty easily. Now, the strength of this joint right now is only being held by a couple of screws. If you put glue on there, it's going to be a little bit stronger, but this is what I wanted to show you. If it's not absolutely accurate as far as the type of material you use, as well as your cutting techniques, we can take a look at how easily this comes apart. And that is exactly what is happening with our modules that we saw earlier. Let me show you a better way. So what I've done now is I brought out my pocket hole jig. It makes a couple of pockets. You actually screw in from the end in this little jig, screw down into the material, and it creates a pocket with a little guide hole. I'll pop that out. These jigs are available in a variety of sizes, from a single with a clamp or even the double like this, and this one can even be removed and used on the side of a piece of wood. Put that back in there. So in a pocket hole jig, this is the same two pieces of wood, except this time I'm setting it on its end where the pocket hole is actually going to come in from the outside. Next comes the driver. It's a square head, and it actually fits in the channel for the pocket screw. You just put it on your impact driver and line it up. Now, enter the two pocket screws into the pocket holes. And since these screws are self-tapping, it's just a matter of lining it up and driving the screw. And with that, we now have our right angle. And if you take a look, it's actually a little stronger than the screw that was driven in from the side. Now, when you couple this with glue, that is an extremely strong joint. But there's even a better way, and I'll show you that next. So here's my setup. I actually have a long piece of plywood, what I'm going to use for the side. I now replace the end, instead of using another piece of plywood, I'm going to use a block. This block represents the corner of the module, and it is perfect 1.5 inch square. Literally, I'm just going to line it up with the bottom on a flat surface, hold it together, and using pocket screws, I'm actually going to bring them together. I could use as many as I need, or as few as I need, in order to hold it together. Now, with the ends driven from the inside, you'll never see it on the outside, and the alignment is perfect. No sanding required. Now let me show you what I'm going to use. In order to make sure that my corners stay absolutely square and have the maximum amount of strength, I put in a couple of dominoes. This dominoes has a corresponding slot on the corresponding board, and they fit together like a jigsaw puzzle. Actually slides in rather easily. And you can see it already is aligned from top to bottom, front to back, and as well as along the front. All I do now is I put glue on the edges as well as in the dominoes, and I put it together with a single pocket screw. Not only does it hold together, but is phenomenally strong, and it will never come apart. That's how we're going to do it. I brought out all the parts I needed to make to another frame, and I brought out the original frame to show you what's going on. So we have our cross members on the outside on 3 sides, but on the inside of this block you'll see that there's a gap between here, so our cross member is actually on the inside of this block. Now let me rearrange these to show you what's going on. Here's all the pieces I'm going to need to create another frame. Now I need to arrange these in such a way so I can create my joinery. So let's go ahead and do that now. Now I've created the outside of the frame as where I need it to be. Now I have a couple of options on the inside. I can actually make these and create the joinery where the options are to the outside of this particular block. That just means that these are going to be butted up together. But let me show you a couple of other options that can be done. I can have these split, which is what you saw in the original, and I can even bring the back end of the back of the module, let's say this was the back, inside as well. Now there's a couple of reasons I would want to do that. One would be if I wanted to put in a backdrop, whatever height that you want, you could actually seat it in the back and it would be only up to the front of the block, making it real square. The other thing that I can do with that also is I could drop a leg in here. Now a leg can be done, it's still 1.5 inches. I'll just use another block as an example. I could drop a leg in here if I needed to from a supportability standpoint. And this is a perfect 1.5 inches as well. So let's cut the joinery here and put it all together. So last thing I want to do before I glue this final up is to show you a little bit about orientation. So in this case we're actually going to have the supports in the center. But if I wanted to put this along the back, now would be the time to do it. So I take my rectangles and I can move them next to each other and glue and screw them this way. But in this case, we're actually going to have them done this way, where we actually have the center supports. I've already made marks and cut for dominoes. Now what I'm going to do is glue this thing up. I thought I would take a moment to show you where we're at in the stages. So I just completed this one and I've finished building its basic framework. And as you can tell, it basically has the sides, the bottoms, and it's been glued and screwed together. Now, I'm going to add a few ribs here, and that's what I've done down below. Let's move this out of the way really quick. So down below I've actually added a couple of ribs, and they are literally 1/2 inch pieces versus the 3/4 inch pieces. We really don't need the 3/4 inch pieces. They're really too thick anyway, and it adds too much weight. Now I've added a couple of possible sizes here. I have a full height size, and then I have a half height size. I really don't need the extra weight in there, so I've cut them down in half. I've also cut a channel in already for the module top that we're going to put on this. And that is due to the wiring that you saw from the original modules. I've also cut out one rib because there's a switch that actually sits right here. We really don't need this anyway from a structural point of view, so the one will do just fine. If I needed to add another rib, I can add that anywhere along the place that I want to go, and they're just put in with pocket screws. I've also added a couple of knobs on the end with T-nuts on the back to hold the module together, and they're aligned with some Pattern Maker's dowels. With that, we're going to start the process of actually putting on the top from our old module, and we'll get it aligned. Okay, I want to stop here just for a sec to show you what's been going on. Our old module has actually been disassembled. The screws have been taken out and the module's been carefully lifted off. As you can see, it's still intact, and the top board is still intact along with its wiring. With that, our channel for our new module is in place, but I've also cut off 1/8 of an inch along the edge, and you'll see why that's going to happen later. I brought out my small camera here so I can show you what's going on with the sides. I've temporarily aligned the top to the module where it's going to be sitting, and I've actually aligned it along the back face. As you can see, I put an additional piece along the front of this module. This was made out of plywood, and plywood tends to chip. So I actually glued on a strip a little over a 3/8 of an inch wide, and that's going to serve two purposes. First, it's going to strengthen the module top because it has been plywood, but it's also going to sit over the end a little bit. And the reason for that is that when this end is actually flush, this module bottom will actually be flush with the side, and now you can use this to actually set additional pieces on there. What I do then is I take my square and I make sure that it's perfectly aligned all the way up. Okay, as you can see, that's a little bit of a difference. Once it's aligned all the way up, I can bring the track line all the way up to the front. With the track line up to the front, I can eliminate or try to eliminate any of those 3-inch pieces that you see. So let's go ahead and screw this down and start that process now. The module is going to sit literally within those channels, and all I really have to do is align it with the front section, make sure it's square, and then I can reuse the same holes to drill it down. There's one difference I'm going to do here though. The first lockdown is going to for alignment only. The second lockdown is actually when we're going to put glue on this. Now you'll see there's going to be some holes and things I need to fill, but with standard scenery material that'll work out just fine. I will take the other module when this one is complete, align it with the other side, and then I can move down the line. So let's get started. Before I start gluing anything down, I wanted to take a look at how I actually disassembled the module bottom from the original piece. If you take a look, there was no glue actually holding any of this down, so it was rather easy to get off. There was actually slotted screws, which actually dates the piece to well within the 1990s. It was painted, and of course the extra rib was put in later. As you can see, I had to chisel out a little bit to get it started, but the piece itself actually came up relatively simple. Okay, I want to take a little time now to show where we're at in the process. This is one of the end modules, and it's actually linked up to the module that's going to connect to it. There's a couple of dowel makers pins in, and they're actually locked in place with a couple of knobs, 5-point knobs, and some T-nuts. The alignment was actually really good, and I'm going to bring out my small camera here to show you the tolerances and the difference. So if we take a look along the end, I'm going to show this to you. You can see that there's very little gap, actually all the way across the module, and that's literally what...
Okay, I brought out one of our retro modules that has already been sanded. The top from the other module has been removed. It's been placed on top of here, been squared and screwed down. A couple things I want to mention in this. First, I cut off 1/8 of an inch on each end and made sure that it was absolutely square so I can add additional piece. I'll show you why that's important. I did that on both ends. The front has been sanded smooth. It's been aligned properly, and for the most part it's exactly like you saw it before, with a couple of exceptions. Let me start where those are going to be. If I turn it to the side, you will see now that the wood extends all the way to the top of the module versus having a piece of plywood which is open face. This is going to reduce any of the splintering that we have earlier. I'll show you why that's important when we attach our other side. There's some additional holes here that you're going to see. First of all, there's a handhold here, and that's important for when we place it into our module case. We'll turn it around to the other side. On this side, you'll see a couple of additional things. First of all, you're going to see a couple of locating pins. Those locating pins will help the module align for each time. The wood has been put down all the way to the top, as well as the additional holes. And inside these holes are a couple of T-nuts. Those T-nuts help me to hold the thing together. I'm not reliant on the C-clamp to do that for me. So let me go ahead and get these two modules together in their final format and show you what it looks like. Okay, I flipped the module back up on its side so that I can give you an idea what's going on underneath. First of all, you'll notice that this rib has been removed. There was a reason for it. It's because underneath here there's a switch that I need to account for. Also, there's been channels that have been laid into each of the ribs to account for the wiring that was already there. If this was a brand new module, I would just cut holes in and do it this way. But the wiring was already there, so I cut a couple of channels. The ribs in this case are actually half height. It makes life a little bit easier. It makes the module a little bit lighter. They're already a ½ inch. And as you can see, I've located them in such a way that I'm not disturbing any of the modules. This one is slightly off to one side, as well as the other one. So I'm going to set these up for both of them. And as you can see inside, that the locating pins are in place. They don't protrude out from the bottom, so you can actually do what you need to do with this. So I'll set this up with both modules and we'll move on to the next step. Okay, time to show you how these locating pins work. I have the modules set up end to end, and all I really need to do is to put them close together and actually align them. I'm going to go underneath, and I'm going to use these knobs that are screwed in from the bottom. There's a couple of T-nuts on this side that all I'm going to do is screw it together. So let me go ahead and put this up on its side, screw these together, bring this back down, and you'll see that the tolerances for the connections are actually perfect. Be right back. Okay, I've moved the modules and locked them close together, and I wanted to show you a couple of things. First of all, it's hanging out over the end just under halfway, and there's no deflection at all. As I move in closer, you can see the alignment is really good from those pins. And I'm going to even come down to here. If you could take a look, that connection is going to be really, really tight. And I'll actually use my other camera to do this. But as you can see, it may look like a gap, but it's not. I'll show that to you here in a second. So hold on. Okay, let's take a look at the gap between here. So I have the module set up, and I'm going to use my additional camera here. As you can see, I know it's kind of hard to find, but as you can see that the gap between the two is very small. Okay, that gap that you see in the black is not the gap, it's the paint. If I bring it in even a little bit closer, and here's a good shot between the two, I can't even get my thumb between the gap. Okay, I do have one where it was prior painted, then it was painted, so you can see the gap much better, and I will actually show that. So the connectivity between the two is very good. So what this is going to do, it's going to eliminate putting a 3-inch piece of section because of the gap issues. You can bring the rail right up to the end, square it across the top, or maybe use a piece of wood in order to square it perfectly to the end, and then you won't need those 3-inch pieces. As long as the alignment pins are in place, everything should be good to go. Well, I'm not sure about you, but when I go to a show, I certainly don't want to transport my modules this way. First of all, they're out in the open. They're going to bounce around. There's no way to really tie them down very cleanly, even though I have tie downs in my pickup. I want to transport them on the bottom. I really don't want to transport them where they're on their side. That's not beneficial to the module. Also, if I have a third module, let's say this one was my third one, there's no place to put it. I still have the room, but there's no place to put it. So let me show you what our idea is for transporting these modules. How about a module case for transport? This modular case stands 41 inches off the ground, which is a comfortable height for watching your modules. It's modular in and of itself. The top comes off. Each one of the pieces come off. The center section and the bottom section are all modular. It has doors on both ends, which are actually removable. I can transport my modules with ease, take them out, and actually use the top as the legs for my system. It features enough space on either end to actually connect a module on this end going this way or this end going this way to act as a bridge for additional modules. When I'm done, I literally take my module out, place it inside, put my door on, and I'm good to go. I also have, in this case, I have a drawer if I want to carry some additional things with me to the show, such as rolling stock, electronics, things of that nature. There are doors on both ends, and literally I can take this apart and reassemble it back inside the pickup. I can get 2 of these in my pickup, and inside a 6x12 U-Haul trailer, I can literally get 15 modules. That's the module case. That's what we're working on for next time. And so that ends this section on building a module, at least the way that I do it. In this case, we're actually able to use this module frame for just about any module configuration you want. You could theoretically make it longer, you could make it wider, but the standard 2 foot by 4 foot dimension is usually king in the module world. I can put my ribs wherever I want, and I could put different varieties of the top on this, whether I use a single board across the top or a complete piece of plywood that goes along the entire infrastructure of the frame. Make sure that you take into consideration of how you're going to do your wiring, if you need to put holes in there. Also take into consideration how you're going to connect it up to the module next to you. This frame does exactly what it's supposed to do. It's light, it's strong, it won't rack, and it gives you the ability to make your configuration any way that you want it. This concludes my process for building and retrofitting modules. Whether you choose to build your own brand new, there are several techniques you can do to put a module on top. I just used this time to actually retrofit the 2 modules that you saw in the beginning. It can be done to save what you currently have. The modules themselves are really light. What they do is they allow you to actually manhandle these without chipping or breaking. The ends and the sides are very strong. They're not going to rack, they're not going to come out of square, and they're going to be limited to how much chipping is available to them. As long as you protect it with paint, it should last you quite a long while.